Assalamualaikum warahmatullahi wabarakatuh. Hello, greetings from me. My name is Muhammad Abdul Haq. I'm from Komputer and Engineering, Politeknik Elektronika Negeri, Surabaya. This is my presentation video. The title is Peningkatan Kecepatan Proses Deteksi Bola dan Deteksi Obstacle pada Robot ERSO menggunakan Omnidirectional Vision berbasis Robot Operating System. And my first advisor is Mr. Iwan, and the second advisor is Mr. Bima. In this presentation, I will explain about my research. There are outline: the introduction, the problems, limitation, purpose, resource condition, the flowchart, and how I improve the speed process, and the last is reference. Before we start further, this is the introduction. This research delivers a novel approach for improving the computation speed of the ball detection and obstacle detection process in our robot. The speed condition of obstacle and ball detection is still slow and makes the robot real-time and robot movement is hampered. To increase the speed process, there are too many ways. There are optimizing the OpenCV library, push library, and implementing ROS, and then minimize the use of too many frames and then send into the base station. And there are three problems: how can robot detect ball and obstacle at high processing speed, and how to integrate the ball and obstacle detection program into the robot operating system, and then how to send ball and obstacle position information to the base station. And the limitation is the sensor used in this final project is a camera with omnidirectional mirror, and this system using ROS. The purpose is robot software can do the ball and obstacle detection at high processing speed, and the ball and obstacle detection program can run using ROS, and the robot can sending the ball and obstacle information to the base station. And this is the resource condition before I did the research, so I record the performance of ERSO robot. We can see the obstacle detection. We get 67 milliseconds and then 42 milliseconds in ball detection. So this is so slow for real time. And then this is the flowchart of my research. The input is omnidirectional camera, and then the omnidirectional camera is used as input and sent into image publisher in ROS, and then divide into two programs. There are ball detection and then obstacle detection. In each program there are a thresholding process, there are color extraction, segmentation, ball detection, and calculate the distance of the real ball or obstacle position in the field with adding the odometry and some calculation method. And then the robot must send to the base station using some network. And the output, the target is 24 milliseconds and the obstacle is 33 milliseconds. So this is the tools and environment for my research. The first is the laptop, and there are omnidirectional camera as input, and the field, and then the robot. So this is the graphic of the robot operating system. The graphic is the first we can see there are Omni image. I take from Omni publisher and then send into two programs, Omni detection and Omni ball detection and then Omni obstacle detection, and then send into the base station. So the vision is around here in the bottom, and then send into the base station. In ball detection, I simplifying process using ROS. So with ROS I can simplify the process, so the process make fast, and then maximize the use of region of interest. So before I did the research, the frame is still big, so I compress or crop the frame so the process is not too big and the process is more fast because the frame is more small. And then I optimizing the frame, so I throw and release many frames that didn't use, and I used the frame by frame. And in the obstacle detection is same with ball detection, but I input the inverted contour in this obstacle detection. So before I did the research, the robot is detecting the black color. I think it's more simple if I take the threshold of the green color. After the green color, I invert it, so the result is like this. So before, this is the threshold of green color, and then I invert, so we can see the obstacle become the white. This is the obstacle. So I think this inverted contour is cut more process, then the speed is more high. You can see that this research did not affected in ball detection performance. So the ball is still detected and still detected well. Okay, the next is obstacle detection. In this video, this proved that my research didn't affected with obstacle detection, because when this detection is more bad, because my research I think is useless. So I must prove that my research is not affect the performance of our robot. And then this is the last result of my research. So I run using ROS and using hidden frame, so I didn't show the frame. So the result is in ball detection there are 18 or 17 milliseconds, and obstacle is 23 or 22 milliseconds. So this is more good, or I think it's better than the target. The target is 24 in ball detection, but the result is better, that is 17 milliseconds, and the obstacle is better than the target. The target is 33, and this is the result is 22 milliseconds. And this is the graphic of increased speed progress of ball detection program. The first is ROS, around 4 milliseconds better, and region of interest around 11, I think 10 or 9 milliseconds, and frame optimization is around 12 milliseconds. In this obstacle detection, there are ROS take 3 milliseconds better, and region of interest there are 11 milliseconds. With binary inverse it take 10 or 11 milliseconds, and the higher effect is frame optimization. There are 17 or 18 milliseconds. And the conclusion of my research is the speed of process that previously 42 milliseconds in ball detection become faster, that is 17 milliseconds, and the obstacle is previously 67 become 22 milliseconds, and the program is successfully applied in ROS, and the information from the ball and obstacle detection can be sent to the base station. And this is the reference that I use, and alhamdulillah I got 2 publications in my research. The first is 2020-27 International Conference on Telecommunication, entitled The Base Station Implication of Air Sorting for Communication Between Robots. So I explained about how the robot communicate, and this is the last step in my research. And the last is IJEX, International Journal of Electrical Engineering in Computer Science, with quartile 3, entitled Improving the Speed of Ball Detection Process and Obstacle Detection Process in Air Robot Using Omnidirectional Vision Based on Robot Operating System. In this journal, I explain all about my research. So the final project is same with this journal. And last word is thank you for watching, and wassalamualaikum warahmatullahi wabarakatuh.